Hello dear students, today lecture number 5 from electric current chapter, numericals on grouping of resistances. See, in the previous video I explained about series combination of resistances and parallel combination of resistances, the equivalent resistance formulas. R series is nothing but if you connect the two resistors in series, then current will be constant, then equivalent resistance is equal to Rs is equal to R1 plus R2. If you connect the two resistors in the parallel combination, then voltage will be constant, then Rp is equal to R1 into R2 by R1 plus R2, or 1 by Rp is equal to 1 by R1 plus 1 by R2. If you connect the two resistors in series and parallel, these are the formulas. Now coming to the first problem, here they connected the 4 ohm resistors in series and 2 ohm resistor is parallel to the combination of series, and they asked to find RAB resistance, the equivalent resistance between A and B. So for this we need to apply series combination formula for the 4 and 4. So if they are in series, we need to add the resistance values. 4 plus 4 how much? 8 ohm. Then 2 ohm resistor in parallel. So this will be A, this will be B. If you observe this circuit diagram, here 8 and 2 are in parallel. So you need to apply the formula for R parallel. RAB is equal to R1 into R2 by R1 plus R2. So nothing but here 8 into 2 by 8 plus 2, you will get 8 2s are 16 by 8 plus 2, 10. So 2 5s are 2 8s are. You will get 8 by 5 ohm will be the equivalent resistance between RAB. Here P and Q are the points. In between they connected the resistors in the different combinations in the series and parallel. So here if you observe, they asked to find RPQ. RPQ is nothing but equivalent resistance between P and Q. Here 5 in series and 5 in series, those two combinations in parallel. Nothing but if suppose water is flowing through this pipe, here water is dividing into two parts. Here water flow is nothing but current flow. That's why I1 and I2. I1 is flowing through this combination, I2 is flowing through this combination. So here current is dividing, that's why these two combinations in parallel. If current is dividing, that will be in parallel. If voltage is dividing, that will be in series. So here circuit we need to simplify as both are in series, R1 R2 resistors, then you can add them. 5 plus 5 how much? 10 ohm is parallel to the series combination of these two. So 5 plus 5, 10 ohm, right? P, Q. Now if you observe 10 ohm, they are in parallel. So nothing but if the current is flowing through here, then current is dividing for I1 and I2. So I1 flowing through 10 ohm, here also I2 is flowing through 10 ohm. So current is dividing means they are in parallel. So we need to apply the equivalent resistance between the two resistors. RPQ is equal to R1 into R2 by R1 plus R2. Here first resistor will be 10 ohm, second resistor also 10 ohm, 10 into 10 by 10 plus 10. So you will get 10 into 10 100 by 10 plus 10 20, 0 0 cancel, 2 in 10 5 times cancel. You will get the equivalent distance between PQ is nothing but 5 ohm. Yeah, coming to third circuit, they asked to find RXY, equivalent distance between the X and Y. For that I simplified the circuit like this. So I will explain one by one. Here 5 in series. So you can apply 5 plus 5, you will get 10 ohm. 10 ohm is parallel to 10 ohm. 4 ohm are written like this. So if you observe this circuit diagram, 10 in parallel. So you can apply R parallel is equal to 10 into 10 by 10 plus 10. Nothing but R1 into R2 by R1 plus R2. So you will get 100 by 20. Nothing but 5 times. You will get 5 ohm. So what you got the equivalent resistance for this? 5 ohm. Now for this 4 and 5 is in series. Why? Because if current is flowing like this, so same current is flowing through 5 ohm also. You will get RXY value here. 4 plus 5 is nothing but 9 ohm. So what is the equivalent resistance between X and Y? 9 ohm. So by using these steps I explain the third one. To next problem, they connect the 2 ohm resistors in the different combinations. They asked to find RAB, nothing but in between A and B we need to find the equivalent resistance. For these type of circuits we need to solve from the end onwards. So here 2 ohm in the series. Why? Because same current will flow through the 2 ohm and 2 ohm. So at A step, so we can apply series combination RS is equal to 2 plus 2, you will get 4 ohm. So in the next step, you can write what you got the resultant value, you will write 4 here. So after that 4 and 2 are in parallel at B step. 4 and 2 are parallel in the B step. So RB is equal to 2 into 4 by 2 plus 4. R1 into R2 by R1 plus R2. So you will get 8 by 6, nothing but 4 by 3. So 2 3 0, 2 4 0, you will get 4 by 3 ohm. So in the next step, you will write here 4 by 3. So coming to C step, so here 2 and 4 by 3 in series. Why? Because same current will flow through the 2 and 4 by 3. So at C step, you can apply R series. So 2 plus 4 by 3, so 3 will be the LCM, 3 2s are 6 plus 4 by 3, 6 plus 4 10, 10 by 3 ohm. So in the next step you will write here 10 by 3. So if you observe 10 by 3 and 2 are in parallel. Why? Because current is dividing at this junction. So current is dividing at this junction, so you can apply the parallel combination at D step. So RP is equal to 2 into 10 by 3 by 2 plus 10 by 3. R1 into R2 by R1 plus R2. If two resistors are connected in parallel combination. So you will get 20 by 3 by 3 into 6 times cancel, 6 plus 10 by 3 by 3 by 3 cancel, 20 by 6 plus 10, 16, 2 8 jar, 2 10 jar, 2 4 jar, 2 5 jar, you will get 5 by 4 ohm. So next step you can write here 5 by 4. If you observe the next step in the E, 2 and 5 by 4 are in series combination. Why? Because same current will flow through 2 and 5 by 4. So R series is nothing but 2 plus 5 by 4. LCM will be 4. 4 into 2 8 plus 5 by 4. 8 plus 5 13. 13 by 4 ohm. So in the next step we need to write 13 by 4 ohm. So at F step, 13 by 4 and 2 are in parallel. Current is dividing for these two. So you can apply parallel combination. RP is equal to 2 into 13 by 4 by 2 plus 13 by 4. R1 into R2 by R1 plus R2. So here 2 into 13, 26 by 4 by here 4 2s are 8 plus 13 by 4. By 4 by 4 cancel. 26 by 8 plus 13 how much? 21. So here 26 by 21 you can write in the next step. And so 26 by 21 and 2 are in a series combination. Why? Because same current will flow through 2 and 26 by 21. So at G step, so R AB, that will be 2 plus 26 by 21. LCM will be 21. 21 into 2 42 plus 26. Nothing but 2 plus 6 8, 4 plus 2 6, 68 by 21. 68 by 21 ohm is the equivalent distance between A and B. Mainly from the end onwards we need to simplify this circuit by following these steps. So each and every case I applied the series combination formulas, parallel combination formulas for the two resistors. Coming to next circuit diagram, here they connected the 72 volt battery and they connected the different resistors, 6 kilo ohm, 3 kilo ohm, kilo means 1000, 4 kilo ohm, 2 kilo ohm. In the different combinations, they asked to find equivalent resistance value and the total current flowing through the circuit we need to find. So for that, we need to follow these steps. So I'll explain each and every step how to solve. See, 72 volt they connected. For this type of circuits, from the end onwards we need to simplify it. So if you observe 4 kilo ohm and 2 kilo ohm, here same current will flow through the 4 and 2. So nothing but 4 and 2 are in series. So then you can apply series combination at A step. Nothing but 4 plus 2 how much? 6 kilo ohm. So 4 plus 2, 6 kilo ohm you can write. Remaining value same thing we take. 6, 6, 3, 3, 72, 72. If you observe at A step, to moving for the B step, 3 and 6 are in parallel, right? 3 and 6 are in parallel to move the B step. So RP is nothing but 3 into 6 by 3 plus 6. Why? Because R1 into R2 by R1 plus R2, 18 by 9, 9 2 times cancel, you will get 2 kilo ohm. So at the B step we can write 2 kilo ohm. So 6 as it is we can take. For 3 and 6 we got equivalent resistance value 2 kilo ohm. If you observe 6 and 2, same current is flowing through 6 and 2, then both are in series combination. So you can write So for the C step, so for the C step, you can write R series is equal to 6 plus 2, nothing but 8 kilo ohm. We can write in the next step. That will be the equivalent resistance value, 8 kilo ohm. Nothing but we don't have any other resistors. So what is the equivalent resistance we got? R equivalent is equal to 8 kilo ohm. So to find the current flowing through a circuit, here I will be the total current. So from the according to Ohm's law, V is equal to IR. So from this, I is equal to V by R equivalent. So V means how much? Applied voltage 72 by what is the resistance we got? 8 kilo ohm. So 8, 9 times cancel. 9 by kilo means 1000. So you will write 1 by 1000 as milli. So 9 milliampere is the total current. So by like this, we need to find the equivalent resistance value and total current value in the circuit. Next problem, in the circuit, the given 1.2 ampere will be the total current is dividing as I1, I2, I3, and they connected 10 ohm, 15 ohm, 30 ohm in parallel combination. They asked to find I1, I2, I3 and also voltage applied in the resistors. So for this, we need to apply the equivalent resistance formula. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So why? Because we have here 3 resistors. So 1 by 10 plus 1 by 15 plus 1 by 30. So here for 10, 15, 30, 30 will be the LCM. 10 in 30, 3 times cancel, 3 into numerator, 1 plus 15 in 30, 2 times cancel, 2 into 1 plus 30 in 30, 1 time cancel, 1 into 1. 3 1 is 3 plus 2 plus 1 by 30. So you will get 3 plus 2 plus 1. So you will get 6 by 30. So 6 by 30 is nothing but 1 by 5. So 1 by 5 is nothing but R equivalent is equal to 5 ohm. 1 by R equivalent value 1 by 5. R equivalent is equal to 5 ohm. This will be the total resistance for this combination. So we got R equivalent is equal to how much? 5 ohm. Now they asked to find what? I1, I2, I3. For that, first of all, we need to find the voltage. Voltage is nothing but total current into equivalent resistance. From the Ohm's law, V equal to IR. So the total current is 1.2. What you got the equivalent resistance for this combination? 5. So 1.2 into 5, 6 volt. So what you got voltage drop or potential difference here? 6 volt. So in the parallel combination, we already know voltage is constant. Nothing but each and every case we got 6 volt voltage. Here also 6 volt. Here also 6 volt. Here also 6 volt. For each and every resistor, we have 6 volt will be the voltage. So to find the I1 is nothing but from the Ohm's law, V by R1. Voltage is constant in the parallel combination by R1. What is the voltage value? We got 6 by first resistor we have here 10. 6 by 10 is nothing but 0.6 ampere. To find I2, V by R2. Voltage is constant and R2 value we need to write. Voltage value how much? 6 by 30 or 50? 15. 6 by 15. 320, 350. 2 by 5 is nothing but 0.4 ampere. Nothing but 2 by 5, 20 by 2 by 5 is nothing but 0.4. So I3 is nothing but V by R3. V means what? Voltage 6 by R3 will be 30. So we will get 610, 650, 1 by 5. 1 by 5 is nothing but 0.2 ampere. So whether we got correct values or not, we need to check with I equal to I1 plus I2 plus I3. Why? Because the total current is equal to sum of the currents of I1, I2, I3. So the total current is how much? The total current is 1.2 and I1 how much? Here 0.6 plus 0.4 plus 0.2. So if you add all these values, 0.6 plus 0.4, 1.0 plus 1.2, 0.2, you will get 1.2. So that's why we got correct values of I1, I2, I3. So we need to find the equivalent resistance. From that I found the value of voltage. So voltage is equal in the parallel combination. From that, using Ohm's law, I found here I1, I2, I3 values. So this is about equivalent resistance.